So if I have x to the fourth minus 2x cubed plus x minus 6 divided by x squared minus 1. Okay, so I have an x squared minus 1 here, and inside, I need to leave a spot, don't I?
Yeah.
Okay, like that? Now what do I do? How many times will x squared go into x to the fourth?
Twice.
How about an x squared? Okay, which gives me x to the fourth minus x squared. What do I do now? And add, right? So I have negative 2x cubed plus x squared plus x minus 6. How many times will x squared go into negative 2x cubed? How many times will this go into this? Negative 2x. Which gives me 2x here and negative 2x cubed here. And what? Change the signs and add. And I get x squared minus x minus 6. How many times does x squared go into x squared? Plus 1?
Yeah.
Which gives me x squared minus 1. Change the signs, and I have negative x minus 5. What do I do with that?
Put it over x squared.
Plus negative x minus 5 over x squared minus 1. Y'all remember this? We had to do it with asymptotes in the middle, didn't we? So we have done it since then. That is long division. First problem on the test, long division. Get it over with. All right, yeah. Now, how about synthetic division?
I like that one. Yeah.
So if I have x cubed plus 16 divided by x minus 2. What goes in my little box? 2. What are my coefficients? 1.
0.
Oh, yeah.
Like that?
Yeah. How do you know when to do synthetic division and when to do long division?
When it says use synthetic or use long, you can only do synthetic division if what you're dividing by has a coefficient of 1 and an exponent of 1. But on the test, it tells you what's in there. Okay, you bring a 1 down. And isn't this 2? 2, 4, 8, and 24. What's my answer? No.
X squared.
X squared plus 2x plus 4
Plus
plus
24
over x minus 2.
Find the number in the box to use solve for x.
Yes, you do. It has to be in the form x equal. We good with this?
Yep.
All right. Next thing on the test, it says, and I'm going to read this to you. Use the remainder theorem to determine if the given number C is a zero of the polynomial.
I don't
Can you
remember how to do this.
read that?
What that, use the remainder theorem
Is that
to determine number C is a zero of the polynomial.
So you have to figure out. Is that the one where you just use synthetic division if it comes out
You
zero?
use synthetic division and you need your very last number to be zero. What? Well, it's easy. It's synthetic division, again.
That sounds like it's like a whole page. Oh yeah, it took so long. I thought you just did it once, and if it was zero, then it was.
Yes, you're thinking the wrong. Yeah, you're thinking the other thing, Kristen.
By the way, is that the one where you have to find all the exponents?
Yeah.
Where you gotta like 1/2.
That was so.
Yes, no, that's not what this is.
Okay. For those questions on the test,
Okay.
I don't any point.
I'm gonna do a hard one.
Like a whole page.
I'm going to do a hard one.
Oh, nice.
Okay.
All right? So what I have is I have a polynomial. And C is radical 2.
C is what we put in the box.
C is what we put in the box. Because it's already in the form x equals. The others weren't, right? So we solved them.
Yeah, but if it's supposed to be with x's, if we're asking if it's x, then why would you put it as x? Why must we change?
Because we always use x equals.
So why are we using c?
Well, they just give you a different letter.
Exactly my point.
It's okay, you can use different letters. There's whole 26 of them. Okay, what is this?
2.
2. What is this?
2 radical 2.
What is this? -5 plus 2 radical 2? And this is -5 radical 2 plus, is that 0? So the answer is no.
Oh, perfect.
That's all you have to do.
Got it.
That is not bad, is it? You good with that?
Yeah.
Okay. Now it says, use the factor theorem to determine if it is a factor,
This one is.
which means we do the exact same thing. Okay? It looks a little different because I have this. I want to know, is this a factor?
And we're trying to find the 0, right?
We're not trying to find the 0. The last term has to be 0 for it to be yes.
Don't you just do
You can just use
one
synthetic,
that
Why does 1 go in the box?
x plus 1.
Because you always do x equals, right? Okay. 2, 1, -16, -8. You want to know how to do this? 2, 2, 3, 3, -13. Yes or no?
No.
No, that's all that is. That's all that is. Okay, so that was called synthetic division. It was called the remainder theorem. It was called the factor theorem. And we did the same thing every time. Right? And guys, this synthetic division, whatever, remainder theorem, that should be pretty easy for you. Because basically it's simple multiplication and addition, right? We're good with all this? All right. Now, write a polynomial with a degree of 4. What does that mean when I say a degree of 4?
So like 4
You should have x to the fourth at the end. Okay? The zeros are 2, -1. Make sure I'm not giving you an answer here. Let's do 2, -2. And zeros and 0, and there are 2 of these. Multiplicity of 2. Doesn't that mean 2 of them?
Yeah.
So don't I have x plus 2, x minus 2, and x squared? Right? So now what? Multiply the first 2 together. Do we need to FOIL them? X squared minus 4 times x squared. So f of x is x to the fourth minus 4x squared. Right? Is that all right?
Yeah.
Because now we're ready to go to the one Kristen said was a whole page. Good thing you do. Okay. So this is what we have. F of x is x cubed plus x squared minus 4x minus 4. It says list all the possible zeros.
So 4x is 4.
Oh, 4x. Thank you. How do I list the zeros? Aren't they all the factors of the last number over all the factors of the first one? What's the first number? 1. So all I need is all the factors of the last number, right? What are the factors of 4?
-2 or 2. Oh, yeah.
This is the thing where it's x to the third gets confused or calculated.
Okay, yes, but what are the factors of this?
Plus or minus 1. Yeah.
Plus or minus 1, plus or minus 2, plus or minus 4. You have to say that first.
I don't remember the difference.
Now, since it's a cube, you can find the first one on your calculator, right?
Yeah.
What did you find?
-2.
You can graph it.
Or you can
Okay,
do
we
polynomial
can do
or
this then.
small.
That's what you did, didn't you?
I always just
Sammy says -2 works. How many answers should I have? 3?
Yeah.
Okay, so -2, which gives me a 1, a 1, a -4, and a -4, right? This is 1, -2, -1, 2, -2, 4, 0.
It works.
How about that? So now don't I have x squared minus x minus 2? X minus 2. So what are my zeros?
-2, -1, and
-2, -1, and positive 2? You good with that? I'm going to take this off and I'm going to walk back where you are for a few minutes. Standing under that light, I'm getting really warm. Inequalities. You remember inequalities?
Yeah. So
All right. sure I give you a problem similar to what's on the test. All right? X plus 2, x plus 1.
Oh no.
You want me to do x minus 1?
Oh, you can do X minus 1 if you want to do X minus 1.
Now let's do x minus 1.
No reason. Dramatic, better. Yeah. Obviously.
X minus 3 is less than 0.
I know what the zeros are.
What?
Yeah.
-2, 1, and 3.
Negative 2, 1, and 3. Everybody agree?
Yep.
Woo!
What are my intervals?
Negative infinity, -2.
I was like, the what numbers?
-2, 1.
Wait. What goes after negative 2?
Uh,
Parenthesis or bracket?
Up.
Parenthesis. Negative 2 to what?
1.
1.
1 to 3, and...
3 infinity. Parentheses.
Okay. Do you see why I stopped you? I want to make sure you know it's parentheses. Okay, now, what number do I use here?
-3.
Okay. Is this negative or positive? Isn't that -1? -1 times... What is it when I can put it in here? -4 times 24?
Yeah.
Negative.
Negative. Yeah. So no.
So it works.
Yeah, it does work.
That works.
I'm tripping.
What do I use here?
0.
0, which gives me 2 times -1 times -3.
It does not work.
Positive 6. Which is not there.
Do I use a 2 here?
Sure.
2 gives me 4 times 1 times -1. That works. And what about the last one? A 4 gives me a 6 times 3 times 1. Nope. So my answer is negative infinity, -2, and 1 to 3.
Is that like the only question about it? It's just like the x is equal to you like that?
Yes. Yes. Except there is one with a fraction.
Oh, okay. I think I remember after that.
You think you remember how to do a fraction?
Maybe.
We have a lot of problems.
I think this is near the end. Right.
I can figure out if I need another page.
Probably. We're going to have to do a graph.
Oh.
Okay. Let's do 1 minus x. I'm trying to get my numbers spread out. Okay. What are my first... They're called crucial numbers, aren't they? Critical numbers?
It's the
3 and a 1.
3 and a 1.
3 and a 1. And then what do I do?
Cross multiplication.
Change it to equal
And then just cross multiplication.
and cross multiply. Which gives me 2 minus 2x, 12 minus 4x.
And you gotta switch and cross the
2x equals 10. Is that what you got? What's x?
Oh, you're not.
Is 2x equal 10 not right?
Yes, it is correct. I was already switching I was switching it over to
So I have negative infinity to 1 that should be a parenthesis. 1 to 3. 3 to 5, and 5 gets a what? Bracket.
Because if it's in.
And 5 to infinity. Right? So, for the first one, can I use 0, which gives me 2/3 and 4? Doesn't work. Now I use a 2.
That does work.
2 and negative 2.
Yep.
That works. Then I use a 4. Negative 2
I think
is greater than negative 4/3.
it does.
No. And a 6. And negative 4/5. Oh, is 2/3 bigger than 4/5?
In negative 2/3.
Well, that's true. Yeah. So can I switch it to 15ths? Isn't this negative 10/15ths? And this?
Well,
This one's bigger, isn't it? So that works. Variation.
this is what we just did.
This is what we just did.
This is what we just.
Just as in Friday. Directions say find the constant K.
This is so.
How'd you do with it?
I haven't done it yet. My plan is to do it.
Okay.
It's just like.
Y varies directly. Directly. So X is 8 when Y is 11. So doesn't this mean 11 equals 8K? K is 11/8. Right? Okay. Now, Y varies inversely. Yep. Inversely as X. So Y is 12 when X is 7. So don't I set it up as 12 equals K over 7? $84? Did that make sense, Kristen? This was pretty simple. And the last one is Y varies jointly as W and X. So Y is 20, W is 15, X is 12. So we do Y equals KWX, don't we?
Oh, yeah.
So 20 is K times 15 times 12. Is it 1/9?
Sure.
Well, isn't it?
K equals 1/9.
Yeah.
I'm gonna get an A on this test.
We have one more thing to do. We saved till the end. I saved this till the end.
New lesson right now.
Huh?
Oh, asymptotes.
Asymptote.
Oh, no. Oh, wait, actually, what kind of use graph here?
Asymptote.
They're fine. It makes sense.
You just plug it in your calculator, I think.
Well,
Oh, maybe you can graph it on your calculator.
half of x is equal to 3x squared minus 5x plus 2.
It's the vertical and horizontal and the slant. And the end is greater than end. It's like not there. If it's less than end, then it's in the middle.
I have no idea what you're saying.
Bro.
I thought this is where you just solve on the bottom and then, yes, you have -1 and then you solve for 0.
What is the vertical asymptote? X equals. Okay, on the test, you do not have to write the asymptote, but you have to have it graphed correctly. And I say that because you don't have to put x with it. But if you write the asymptote, you have to. You don't have to write it. Does that make sense? Agreed? What is the horizontal asymptote?
How
Wait, is it 0?
how do we
None.
know that there's a vertical asymptote? I'm trying to revive it.
Set the denominator equal to 0.
And they're trying to whenever that doesn't happen.
Right.
Right.
If it's like a square.
There is no horizontal. Why?
Yes.
Top one's greater.
If n is greater than n, there isn't a horizontal.
There
That's
is.
what she said, yes.
There is a slant.
Yes, because if
Oh,
n
I
plus
don't
1
like slant.
equals n, then it's a slant.
That's one.
I will tell you on the test,
Yeah.
you will have to draw a vertical, a horizontal, and a slant.
On the scheme.
No. No. How do I do a slant?
You have to divide it.
It's 3
I kinda
over 1.
forgot.
Right? No, just
You
kidding.
gotta divide. You're thinking horizontal.
Do
Let's
a,
do it horizontal.
Can you do synthetic for this?
yeah, you could.
That's a lot of work.
3x gives me 3x squared plus 3x. Change the signs.
3x minus 8 is equal
3x minus 8.
Whoa.
You gonna do that by hand, or you gonna graph that on your calculator?
By hand.
Of course. -8.
3 over 1.
So here is my asymptote. Here was an asymptote.
And then you can use your calculator.
To graph it. Because I don't know where a piece of it is.
You need two lines. You need to be seeing 2 different lines on this whole. Right?
I what?
Don't you need to be seeing 2 different
I better have 2 pieces. Yes. Well, I know if x is 0, y is 2. Because when I put a 0 in for x, don't I get 2? Huh?
I don't think my window is big enough.
Can you give me, is that where 1 is?
Yeah, that's right.
Does it come below the x-axis?
No.
No. So it must look like something like this? Would you agree?
Yeah.
Oh, Where's the other piece?
Uh-oh, let me just make my window.
I bet it's down here somewhere.
Oh, I still don't see it.
Okay, let's trace. Tell me when x is -2, what is y?
-24.
So it must be down here. Huh?
You don't have to be entirely accurate with it.
No, it's a sketch.
You just have to make
Do you agree it's down there?
Well, yeah.
So that's all you have to give me. Now, we only have like 3 minutes. The last thing I'm worried about is, do you know how to do a horizontal asymptote?
Yes.
I think so.
You think?
It
Maybe.
is greater than m, but isn't one.
So if I give you this,
It's
Zero.
one.
Why?
it's y equals 1 because it's sideways?
Oh, yeah.
What would the vertical ones be on that?
Positive 6 and negative 6. Yeah.
Right? And there's not one that hard on the test for vertical. Are we good?
So,
You know